What's good, AP Calculus family? It's Mr. Ford here with another homework tutorial. Here is 6.3.3, and we are not going to be doing 107, but we're going to be doing everything else. And 108 through 112, this is going to be a pretty straightforward assignment. So I think you're going to be just fine. Let's jump right in. Let me pull up my actually, I haven't pulled my answer guide up here a minute ago, which I'll have to re-log in. I'll have to strategically do that, so you guys will never know. Except I'm talking about it right now, so who cares? All right. So for 6108, we have using the graph of f double prime at right. Probably important to point out that this is the second derivative of this graph. We're going to determine the intervals where the original graph, where f is concave up and concave down. And that's incredibly easy to do because if f double prime of x is positive, then f of x is concave up. You know, I should have written this off to the side. If f double prime of x is greater than 0, then f of x is concave up. And if f double prime of x is less than 0, then f of x is concave down. So pretty simple. All we're looking at is where this graph is positive and where it's negative. The greater than 0 is going to happen on this range right here. And the negative happens from here and here, right there. So concave up is going to happen from, I suppose, -3 to 1, where the graph is positive. And concave down is going to happen on two intervals, -infinity to -3, and 1 to infinity. And that is all I have to say about that answer. Next question, 6109. Calculate the area between the curves of sine of x and cosine of x over the interval from pi over 4 to 3 pi over 4. This problem is nice because they gave us the interval, so it's probably a good hypothesis that we could start with an integral from pi over 4 to 3 pi over 4. Now, the only question here is which one's on top and which one's on bottom. Normally, I would say this question is probably a calculator-free question. But since it doesn't say that, I'm going to make our lives way easier by just looking at the graphs on a calculator really quick. I mean, it's reasonable to ask you to be aware of which one's bigger over that range, but let's just go ahead and graph it. We have sine of x, sine of x and the cosine of x. And we're going to graph it from the window of pi over 4 to 3 pi over 4, since that is the range that we care about. Like that, the calculator will automatically adjust those for us. And let's call the interval pi over 4 is fine. And then y doesn't actually matter too much, so we'll go ahead and graph it. There is the sine of x graph on top and the cosine of x graph on bottom. So it looks like sine of x is above cosine of x on that entire range, which is good news for us. So all we need to do is the sine of x minus the cosine of x. And this is all times dx. Now this is a pretty reasonable graph to do by hand also. So this is a pretty reasonable integral to do by hand. So that's exactly what we're going to do. You can use a calculator if you want to, but you don't need one for this answer. The antiderivative of this function, the antiderivative of the sine of x is the negative cosine of x. And the antiderivative of the cosine of x is the sine of x. So we're looking for the negative cosine minus the sine. If you take the derivative of that blue function, you will get the purple function, and we're going to evaluate that from 3 pi over 4 to positive pi over 4. And that looks like it's going to be complicated, but keep in mind that most of these are just sine and cosine values you can grab off the unit circle, and most of them are the same number too. So the negative cosine of 3 pi over 4 is going to be negative square root of 2 over 2. Minus the sine of 3 pi over 4, which is positive square root of 2 over 2, so that's just going to be 0. Minus the negative cosine of pi over 4, which is the negative square root of 2 over 2. Minus the sine of pi over 4, which is also the square root of 2 over 2. So the way this is going to shake out, this is actually 0. Those cancel out. And the second part, you have, we're going to add those together. I guess it's going to be -2 square root of 2 over 2, which actually the 2's cancel out and the minus negative cancels out, so it's actually just the square root of 2. I think. You could confirm that on a calculator by just looking at the actual integral. Should be about, actually I'm looking at the answer here. Yeah, square root of 2. So if you go on your calculator, it's going to be about 1.41, which I hope you recognize at this moment in your life is the square root of 2. So, okay. All right, next question, 6.1.10. Multiple choice. Which of the following expressions is equal to the derivative of the cosine squared of x? So let's think about the cosine squared. It's going to be a chain rule function. The first thing, the outside function is to the second power, is the second power there. So the power rule would give us 2 cosine x to the first power. But we need to multiply by the derivative of cosine, which is negative sine of x. And so altogether our answer is negative 2 cosine x sine x, which I see right there is option 2. So I know that B is at least correct. I think, now I don't like this question too terribly much, and it's not super representative of what you might actually see on your AP test, other than the fact that the format is cool, but the actual question, no. You are expected to recognize at this stage in your life, and I don't know if you recognize or not, because I don't know the pre-calc curriculum too well, but 2 cosine sine is actually equal to the sine of 2x. So there's a trig identity that you may have learned back in pre-calc that says that 2 times the sine times the cosine, or in this case, 2 sine cosine, or 2 cosine sine, is equal to sine of 2x. So those are the same thing. So 3 is actually also correct here. So the correct answer is D. And that's, you got to recognize the trig identity there. 1 is out, though. So I don't like that too much, but it is what it is. Okay, question 6.1.11, part A. For each of the following functions, what is f prime of x? Let's start by, I'm going to write the problem over here and get some room here. The original function is the cotangent of 5x squared minus 2x. That's not super fun, but it's not terrible either. And b is the 1 over the cotangent of x to the 4th power. Okay. So, let's see. With cotangent to the graph, the derivative of cotangent is the negative cosecant of x. So, when it comes to derivatives, the first thing we got to do here is think about the chain rule. The derivative of the cotangent, which is the outside function here, is the negative cosecant squared of the original inside, 5x squared minus 2x. That takes care of the outside derivative. But now we need to multiply by the derivative of the inside part. Use the chain rule, so we'll multiply by 10x minus 2, which is the chain rule part. And that is the answer, I think. That'll do it. You could clean it up a little bit. I'm looking at the published answer. It looks like negative quantity 10x minus 2 times the cosecant squared of 5x squared minus 2x. Not super nice, but that's what it is. For question B, it might be better. I don't know. We could do this as a I don't know, quotient rule seems to be a thing we want to try. But honestly, I think we can make this problem a lot easier for ourselves if we recognize that 1 over the cotangent of something is just the same thing as the tangent of something. So let's make this problem a lot easier for ourselves by applying just a little bit of trig there at the front. So now your derivative is a lot easier because the derivative of tangent is secant squared of x to the 4th. And we need to multiply by the derivative of the inside part, which is 4x to the 3rd. And I believe that is the answer. 4x to the 3rd times the secant squared of x to the 4th. And that will do it. Looking at the last question here, 6.1.12, this is a no calculator thing. We have to evaluate each of the following integrals without a calculator. Question A, and the theme of this homework assignment appears to be, do you remember trigonometry? It's okay if you don't. You get a lot of practice with it going forward. Cosine and secant. That's got to be jumping out at you as a kind of an alarm situation because cosine times secant, that is literally cosine times 1 over cosine. Those are going to cancel out. They're reciprocals of each other. So this problem is actually just the integral of negative 3 dx. Or in other words, the area under the curve of the horizontal line, negative 3, which is just going to be negative 3 times the length, which is negative 3x. So the antiderivative here is negative 3x plus c, and that's all there is to that problem, honestly. Question B is going to be a little more tricky. We got a few more things to think about here. But we are going to have to evaluate this because it's a definite integral from 5 to 1. So let's get to work here. The first thing I would do is I would rather think about this as 5 minus x to the 1/2 power dx. So we got to think about antiderivatives, and we got to think about anti-chain rule a little bit, which is a thing that we've seen previewed on a lot of homework problems and a lot of stuff we've done in class too. So this is a good opportunity. There's a more formal way of doing what we're about to do, but we'll look at it later on in Chapter 7. But however, right now we can handle it, no problem. And the first thing is the to the 1/2 power. We have to use the anti-power rule here. So let's look at 5 minus x. We need this to go to the 3/2 power because the power rule will drop that degree down by 1. But of course, we have to lay a trap for that because when the 3/2 comes down and multiplies, we need that to cancel out. So we're going to multiply this by 2 over 3. That will take care of that part of it because when we take the 3/2 down, it'll multiply with 2/3 and cancel out and then drop down to the negative 1/2 power. Of course, we need one more trap to lay because if we're going to take the derivative of this here, what we would then need is you to think about the chain rule because the derivative of 5 minus x is negative 1. So we need to leave a negative 1 behind to cancel that out also. So let's call this negative 2/3. So we're thinking ahead about everything. Might be better to write this as negative 2/3 times 5 minus x to the 3/2 power. Again, I really want you to stop and ponder that the derivative of this expression here is equal to this expression over here. Again, one more time, I'm just going to talk you through it. The 3/2 comes down, cancels out with the 2/3. The negative is still there, but that goes away when you do the derivative of 5 minus x, which is negative 1. That multiplies by negative 1 and cancels out, leaving just 5 minus x to the 1/2 power. Now, our next job is to evaluate this. We have negative 2/3 times 5 minus x to the 3/2 power. We're going to evaluate this from 5 to 1. So let's very carefully section this problem off. The first part's going to be very easy because if we plug in 5, we get 0 right there, and that's going to make our lives much, 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 much easier. Trying to use colors to show the substitution. Minus 5, that's going to give us 0. The next chunk, though, is going to be negative 2/3 times 5 minus 1 to the 3/2 power. So we are just evaluating this integral by plugging in 5 and plugging in 1 and subtracting. This whole chunk of this is 0. 0 to the 3/2 power is 0. 0 times negative 2/3 is 0. So this whole chunk of the problem is 0 minus. And let's talk about what's going on in this parentheses. We have negative 2/3 times 4 to the 3/2 power. 4 to the 3/2 power, I prefer to think about that as 4 to the 1/2 power, which is 2, and then 2 to the 3rd power, which is 8. So this is minus 0 minus negative 2/3 times 8. And then that's going to be minus negative 16 over 3. So the final answer is positive 16/3. And that is the actual correct answer. Hey, we did it. We got out of here in less than 15 minutes, guys. This is an easy one. So I will see you in the next video. You guys are awesome. The challenge today is going to be in class, which you already know that if you're watching this video. So I will see you guys in the next video. You guys are awesome. Keep it up. I'm very proud of you. All the positive things, all the happy things. I'll see you in the next one.